Okay, so we are discussing about this data, how we are going to process, right? So from the source system to till like final data processing. So basically we have the incremental processing. Okay, so in the incremental process, how we are going to do? So whatever this the data which historically available. So with the historic data, we used to compare with the current transaction. So what we are doing exactly with the incremental. So example, yesterday there is a sales received. So I'll just represent here. So this is my input feed file. So this is a today file. So in the today file, there is a record came with customer ID and customer name and location, price. I'm just adding few columns for reference and product. Okay, so these are the columns are available in my today files. Okay, so in the file having customer ID 1 and customer name is something like David here, and location is something USA, and the price is something like 4,000, and the product is something like laptop. Okay, so these are the record, and I'll add one more record second, and that is Leon, and she becomes to UK. It's 5,000, and she bought some monitor. Okay, so these are the new data which came on today's file. So this is a current transaction file. Okay, so we have a history table, right? That is dim underscore table. Okay, so dim underscore customer. So we have a so customer ID. So we have a customer name and price and flag. Okay, so here we have only the currently historic record 2 is there. Okay, so this came on yesterday. So UK and so 5,000 and monitor. So monitor. So here, if you see here in today's file, David USA 4,000 and laptop. So this is the new record, but this is a historic table. So historic table having only the second record is there. Okay, so and Leon UK 500, she purchased a monitor. Okay, so here in this record, so this is the current today's file and this is the historic. So it will compare with the customer ID. There is a key column should be there in both the tables. The key column is customer ID in both the tables. How it will compare with is, so it will be the unique ID. So customer ID is the one which is unique. Okay, so in the database while processing as a incremental, it will compare with the customer ID in both the tables, and if the customer ID already exists, okay, it won't do anything. Okay, because it's the same record as it is there. Okay, and here first David USA, this is the only new record. So okay, it will insert only this particular record, whatever here it is there, right? One David, only this record get inserted into this table. So second record again it won't insert here. Okay, so it will insert in this table with same record, like one David and USA. Anyone having any doubts? Sorry, any doubts? Okay, yeah.
No problem.
Okay, so yeah, thank you. So here this record get inserted into this table. Okay, because as part of the incremental process, so this record is now inserted. This is the new record. Today only this transaction happened. Okay, so this record already existing in this file. So no need to insert this record again, because if you again insert, it will cause the duplicate, right? So if I insert this record, now I will get a 10,000 as a price, and this will gives the misleading of my data, right? So actual transaction is 5,000 only, but if you insert this one, I will get the double amount. Okay, but actually that sale did not happen in the market. So this is how the incremental process we do the insert and updates. Okay, so the insert and update both will happen in the incremental process. So now what is update? So we have seen the insert, right? So now one record today file came and there is a change of this price example. So now this is priced to, so this 4,000 is priced to 6,000. Okay. So there is a store person mistakenly enter this data as a 4,000, but actually the price of this laptop is something like $6,000. I'm just representing. Okay. So this is the value, but he unfortunately entered by mistakenly with $4,000. So this is the correct amount. So how we are going to update this one? We cannot manually go and update this, right? So what we will do, the source system, again the persons will update in the source system, then again it will be flown into the system, and as part of incremental what this will do is, this will check with the customer ID if any changes. Okay, now this should be updated with the 6,000 value. What it will do again, this will be updated. Okay, so this records get updated with the value one David USA, and it is 6,000 and laptop. This record will be overwritten. Okay, this record will be rubbed up. Okay, so this record completely overwritten, and it is updated with this value. Okay, so if any changes with the data, it will update, and it won't again try to reinsert any data. Okay, so it won't reinsert the data again. It will just, if you reinsert, so you will get land up with the duplication of data. Okay, so this is how insert and update will happen as part of the incremental process in data warehousing system. We will compare with the current transactions with the historic transactions. If any new record comes, it will get inserted. If any existing record will come, it should get updated over here. Okay, so that's how fully structured layer having the historic and current transaction. This is the final table. Okay, so we are doing the 3-layer filtration of our data. Okay, so this is how the data warehousing data process will happen in real time. Okay, so hope this is clear. How we are processing in Synapse, or so again, see, I'm saying you right. So most of the data warehousing process, we used to do all these filtrations based on your data. At a time, if you do all this data structuring, right, it will be clubbed up. Example, I wanted to do all this process in a raw layer. It is not possible, and you will landed up with the data mess up. Okay, so that's why we are dividing in a multiple layer based on our requirements. Okay, so even though if you take how like filtration criteria, right? So if you take any filter, water filter or something, what it will do, it will take the raw water and step by step it will filter in each layer, and it will produce the quality of water. So similar way here also, the data what we are doing, we are filtering in each layer, and finally we are producing the quality of data. The output whatever we are getting, that quality data or a structured data, we are giving this input to the Power BI dashboards or Tableau or any dashboard which we are going to show to the clients. Okay, so this is the 3-layer architecture, and similar way we have a delta process also. I'll explain that in while explaining my classes, but similar delta processing also similar way it will happen. Okay, so so this is like enterprise data warehouse model, how we are going to filtering. So we will call it as EDW model. So EDW model is like enterprise data warehouse model, which um, we used to filter out the data in the all particular layers. Okay, so this is how it works. So now um, I need to explain before I start some other things. So I quickly give some more glance about this blob and ADLS storage. Okay, so let's quickly walk through that one as well. So basically, there are two storages which they introduced. Okay, Microsoft. So these storages are, first one is like I'll represent it as blob or gen1. So this is blob or gen1, and another one is like we have a ADLS gen2. Okay, so we have two different kinds of storages which Microsoft is extensively offering to store your data. Okay, so I have represented here blob and gen1. So these two are same. Okay, so this is a generation 1 which Microsoft offered. Okay, so example, you have a file, and that file you need to store, like you have a example, you have in your system having the C drive, D drive is there, right, to store your personal videos, photos, files, personal documents, everything you can store it in your drive, right? But Azure, if you don't have any storage account to store your files, you cannot do any data processings, right? So that's where they introduced this storage accounts. What especially this storage accounts will do is this will store the details. Okay, detailed data, like whatever you have a image file, you have a audio file, or you have a video file, and you wanted to store the company documents, everything. They are providing the high performance storage accounts. Okay, but in this Gen 1, the only drawback is you cannot store the data in a hierarchical manner. manner. Okay, so what that means? What is hierarchical manner? Okay, so example, you have a country. So in the country, so here what will happen is, um, so I'll create one folder called country in the blob storage account. Okay, so what this will do is you cannot give, so there are various countries, right? So in countries means we have India, US, UK, Australia, there are various countries. Business having various countries relationships, right? So they used to get various countries files on day-to-day basis. Okay, but in the blob storage, what will happen is we don't have any hierarchy. So how the data will be stored is all the data get clubbed up here. You cannot divide USA in a different folder, or UK is in a different folder, and Australia is in different folder, or India is in a different folder. You cannot make any individual folder in this particular root folder. You can create only one folder, that is country, and all files will be seated in this country folder. Okay, you cannot create any individual folder here. Everything get clubbed up. So again, this is a problem, right? So how I can identify how many US files today received? Example, today business in USA. So how many sales are happened? How many input feed files I have received? It is very difficult to identify because this contains, it's not only one day data, right? It is having the historical data also, files, input feed files. And it is bit challenging for the developers to or supporting person to identify what those files and what how many files, whether today file received or not. He does not know until he went into that. If he know any file name and with the date and sequence number, if he know, he can search it. But to identify this particular folder, like we don't have any folder inside that, whether it's a today's file or yesterday's file or it's a 4 month back file. It is very difficult to identify in the this kind of mechanism, especially in the blob. Okay, but scalability is there. Scalability wise, how whatever the ADLS gen 2 will give, that will provide the blob as well. And the performance wise also it is good, and you can load more data as well. um, Everything is fine except this one, right? So and also one more another thing is delta lake process. It is bit challenging in the blob because we don't have hierarchies, especially for the delta lake process. So we need the delta layer, like versions, everything you need to maintain. But I'll show that one, no need to worry. Okay, so these are the complexities by using the Gen 2, but this one completely decommissioned by Microsoft, no longer supporting. So after December 2023, they decommissioned this one. So no longer now Microsoft is supporting this 20 this blob on Gen 1. So now all we have is Gen 2. So generation 2 is the one which we are using currently. So we migrated all this blob on Gen 2, Gen 1 to Gen 2. So now we have Azure Data Lake Storage. So this data lake storage, you can store the similar data, whatever we stored, like audio, video, and important documents, files, everything, similar thing, whatever we are doing in Gen 1, you can store everything. But only thing here, main update is you can maintain the hierarchies. Okay. So here, let's add that. Okay. So we have a country now. So what I can do is I can make the hierarchies. So in this hierarchies, so now what I can do is I can create individual locations. So for USA alone, I'll create one folder, and UK alone, I will create one folder, and Australia alone, I can create one folder, and India. So I can make the individual folders for each. So let's get added up here. So India and USA. So UK and Australia. So individual folders get added up for inside the country root folder. So this is my root folder, right? So country is the root folder. In the root folder, I have the all these subfolders. Okay, so that I come to know India files will be placed into the India folder, US files get placed over the US and UK and Australia. Okay, so all these files get clubbed up in the country level. So now I have a countries. So these are the 4 countries which we are operating our business, and business files will be get placed in each individual country location. Okay, so and one of the benefit is, so we can process all our big data objects. So you can keep more data compared to blob higher. So they have extended the scalability and performance, and we have a partitioning and it supports more like a delta lake. It supports more delta lake and data lake, all the data process. It support robust, okay, because these are having all the hierarchies and proper data manipulations, everything. You can store unlimited data storage, and performance wise, all those things, it will be good, okay. Data lake or delta lake. So we have a two different process, data lake and delta lake. So all this process we can store in the data lake gen 2. Okay. So this is more like a storage specific. You can store all your input feed fields and you can process the data. So this is inbuilt come with the Synapse. So while configuring, right? So Azure Synapse, you are configuring with ADLS Gen 2. So while you are tomorrow session, I will show how to configure. So in Synapse, so you are going to add this Gen 2. Okay, this comes with the Synapse with ADLS Gen 2 storage and serverless SQL pool 2 we are going to configure with the Synapse analytics. Okay, so this is how the storage will work. And so all the processing, whatever the data, everything we used to keep in our data models, everything we can keep in the ADLS Gen 2 layer. Okay, so hope this is clear. Anyone having any doubts? I have explained right earlier, like in Azure Synapse, we have various data modules and data process, right? So let's quickly go on here. So main thing in the data ingestion perspective, so we have various levels of data processing. Okay, like we used to use Python, SQL, and C Sharp, and all these coding practices which we used to use, but we need at least two languages should be familiar. Okay, either you need a PySpark or either you need a SQL. Okay, better to have PySpark is an advantage because we used to use all the Spark commands in the um, uh, data coding perspective. Okay, PySpark and SQL, these are the two languages which we used to use to write down the transformations in the um, ETL perspective. Okay, so that's how this works. So let me go on here. Okay, so we have a Spark, right? So I have mentioned the Spark. So what this Spark, and again it's a Spark also a open source, you guys already know. So basically we used to use for the big data processing. This Spark is one of the important pool which gives the data processing as a robust data processing, because Apache Spark and Spark, so both like if you take the PySpark example in Databricks, we used to use the PySpark commands so data frames and so all those things, there is a terminology but I'll explain most of them, but now if I explain you will get confused. So these Spark commands are very important, how to read the data and how to perform the transformations and how to load the data, and all those things are very important, especially the transformations will happen in the Spark layer. Okay, so in the Spark basically you have various kind of functions like we have RDDs, data frames, and we have various mathematical functions and aggregations, and we have some functions like row number, ranking functions. Similarly SQL, how we have, right? So similar functionality which we are having in Spark, and you can do whatever the machine learning or data engineering perspective, you can do the data analysis before loading into the Power BI itself. You can represent the trends and you can observe how the data graphs are coming, like whether whether your data is a proper data or is there any issues with your data. Everything that analysis you can done by using this notebooks. Okay. So that is one of the benefit of using this. But the whatever the full-fledged data processing you can see only in the Databricks. But Apache in Azure Synapse, right, we have a limited functionalities. Whatever the code it is there, so that code output we can see. But graphical representation, everything, if you wanted to see in Azure Synapse, it's not possible. It's more like you can do the transformations. Okay, but in Azure Databricks, you can do the full-fledged set because Azure Databricks is one of the full set actually. Okay, so this service is added in the Synapse. Okay, with the limited functionalities. Okay, but you can use these languages as whatever we are using, but some of the functionalities it's not added in Synapse. But whatever required, it is enough for us. Okay, because we do more like data structuring only here, so that is enough for us, our data processing perspective. Okay, so so basically like we have all the Spark pools, everything. So to create all the Synapse Spark pool and dedicated SQL pools, so once we create the Azure service, right? So we have various options. You could just create this pools. You have a option once you create some pools, so we can just click on the new Apache Spark. I will show everything once we start the lab, and new dedicated pool we can create here itself. Okay, or after creation of Azure Synapse also you can do that. Okay, so we have various options to do this one. Okay, so going forward I will give those complete details. Okay, so this is just the second way. In the manage section, we have a manage section. In the manage section, you can create a Apache pool. If you wanted to create Apache pool from after creating the Azure Synapse, so you can do that. You can create this one here and Apache Spark pool. And once you create, click on new and you could create it. Okay, so this memory and size, everything is like you will be chosen up because see, make sure that so this size of the node and everything. So based on this, similarly like how your computer, example, your computer have 4 GB RAM and you have 1 TB hard disk. So 4 GB RAM and you have installed multiple applications and your system gets slowed down, right? Similar way, you need to think about your data while designing. So you are having you need a high performance node or low performance node. Based on your data, you will get chosen up here. These settings, I'll explain those while creating. So based on your requirements, we will just create how many number of nodes required and how many number of driver and worker nodes. Okay. So let's quickly explain the Spark architecture, how the Spark architecture works basically. So Spark architecture is one of the important thing while working with the Spark. So let's quickly open up here. So Spark having the architecture is so basically driver and worker node architecture we have. So I'm just giving like this. So we have a driver and worker node architecture. Okay. So we have a driver and we have a worker. And in between there is a cluster. So here is a driver and cluster, worker node, and here also worker node and driver. Okay, yeah. So this is the architecture. So basically driver and worker node. So what is this driver and what is this worker? So Uh, so how, let me explain this way. Okay. So example in our project, okay, one team lead is there. One team lead is there and you have a 10 different tasks. Okay. And the client given the deadline that this should be delivered in within 10 days, the project. So now you have only one team lead and he is also having the limited technology knowledge and you have only five resources and you need to complete 10 different coding uh, tasks. Okay. And you have only five resources are there. That resources, they are good in technically, but they cannot complete, right? So within the 10 days, 10 different tasks, and those are very large tasks. It is not a small task. Okay. So now what is the option here? So we have only one team lead and that team lead don't know some of the technologies, and he need to understand, either he need to learn or he need to understand, but that is again, there is a challenge, right? So he cannot understand whatever he know he can understand, but without his limits, so he cannot understand what client is saying. Okay. So that's how there is a challenging. Now what we will do is, either we need to hire one more lead who knows that particular technologies. Okay. And also we need the strength of our uh, employees. Like we need to hire two more resources because we have 10 different tasks. We have two short deadline, and it's a bit difficult. Even though if they work on more hours, they will get stressed up and they won't deliver a proper quality of data. Client always they will expect the 100% or 90% quality at least. Okay. So if they done something, it will be a negative mark for the that particular company, right? So now the situation is need to hire in one more lead and two more resources so that flexibly they can work and they can produce the quality of deliverables. So similar way, uh, in Spark architecture as well, you are dealing with some 20 TB of data. Okay. So you are dealing with 20 TB data and you are using only one driver and two worker nodes. And you have one cluster. That cluster, even though it's a high performance cluster I have installed, okay. So this 20 dB data, I will distribute 10 TB to one worker node and 10 TB to another worker node. So 10 TB is not a small amount of data. It's a huge amount of data. So if we have divided, so internally it is divided with 10 TB, 10 TB. Even though this is not enough actually. So these two worker node get pressurized, and whatever the signals passing from the driver, it is very difficult to grasp this 20 TB data, and your system performance or whatever the data processing speed. Your data processing speed depends on your cluster and your driver. Okay. Similar way like your team lead. So your team lead did not understand. He is giving some approx inputs to you. You cannot do the work, right? So you will stuck up. So similar way here also same thing. So you don't get proper signal over here, and this two get pressurized, and this will get hanged up. Okay. So for that reason, we have a flexibility. You can increase the driver nodes based on your data. You can extend your driver node and you can increase some other worker nodes based on your data volume. So I'll increase now worker nodes. Okay, so that similar way how it is distributed, right? So it will be distributed the all the data sizes now. Okay. So it will distribute now like so now 20 20 TB, right? So in the 20 TB here here it will be populated some 5 TB. Here it will be distributed, and here it's a 5 TB. And sorry, I'll just present here 5 TB, and here it's a 5 TB, and here also 5 TB. Okay, so now 20 TB is distributed accordingly, and we have a drivers. So this driver will take 10 TB amount of data, and he can flexibly distribute those, he can analyze those data, and these two drivers will be delivered the proper output. Okay, so this way your driver and worker node architecture will produce the data in a high performance manner. Okay, so driver and Spark architectures are very, very important, because based on this only your data movement gets speed up. Okay, if you don't have this proper mechanism, so you will be landed up with, so in real time I have seen various scenarios, because um, there are two challenging things are, one is with the coding standard, another one is the your cluster coding. Anyway, you will developer will write some code, and anyway he will load the data. Okay, and second thing what we observe frequently is this performance issues. So these performance perspective, first you need to think about your data, what is the volume of data you have in your source, and what is the cluster you are using, whether it's a high performance cluster or a low performance cluster. So we have a vCore model, and we have a DTU model. There are various model, DBUs model. So based on the model you need to choose, and you have a uh, based on your input data you will choose this worker nodes. Okay, so I have a high performance, I need more workers, I'll take 8 worker nodes and I will distribute accordingly. But make sure check your volume before you decide it. You need to check, you need to understand as a developer perspective, what is the volume of data you are getting per day, so that you need to take this decision, because it is in the development phase, right? If it is a support phase, it is a different scenario. As a developer, you need to understand how you are dealing with this data. As a data scientist, data is all for you. So if you analyze the data, your output will be get proper, and your process get will be the optimized manner. Okay, if you did not understand what is your data, you will be landed up with the wrong solution, and you will landed up with a bad performance application solution. Okay, so obviously as part of solutioning everything, you need to be clearly understand the data movement and everything, so before we design the application. Okay, so when we started our designing also, we may get so many roadblocks or challengings, everything. So to overcome, we will do some load test. Example in real time, before we release to production system, right? We do the system load testing. Why we do this system load test? Because your system should be capable enough to handle it. Even though there are 200 users are coming to access your application should be stable, and your application should provide the um, output whatever we are getting for one user or 200 users, everyone should get the proper result. Okay, so that's how your designing and processing will be decided. Okay, hope this is clear, the architecture process. So going forward, I'll explain some Spark commands also. Once we start the Synapse creation, workspace, and everything I will explain. Okay, so no need to worry how these things are happening. Okay, so these are all internal process. We cannot see actually. So these are all the internal, how the internally the Spark working, and how it is defined. Okay, so this is how the architecture works. So this is how we have created this. Anyway, this Spark pools creation I have represented, right? Node size, vCore 64 GB. So that is the main agenda which I have explained. So these you will be chosen based on your data volume. Okay. So we have a delta lake. Okay. So delta lake is one of the important process. If you take in Databricks and if you take in Azure Synapse, so everywhere this delta lake process is very, very important. Okay. So what is this delta lake especially? So example, the delta lake is specially designed for to keep historic data and current transactions data. Like you can perform the data processing, like you can do SCDs and you can do, so we have a SCD type 1, type 2, type 3s, right? So I'll explain, might be most of you guys are working in real time, you guys know how SCD type 1, type 2 is working. And okay, how we are see, based on the SCDs we are going to uh, process our data, our dimensions, our facts, everything get populated. So to process this incremental data, so this delta lake process, what it will do is it will create the versionings. That is the beauty of delta lake. So delta lake will provide the versioning. Okay, so what it will do is inside the delta folder it will keep on creates the versions. Suppose example yesterday file is generated, it will create one version, and tomorrow there is a file going to create version 2 and version 3. Like that it will create internally inside the file process, and whenever you run the data it will give the example you are trying to populate the historic data. Once you run the historic version, you will get to know what is the history data. Okay, what on all your history data, what is your current transaction data, everything get you can show up in the delta lake process. Okay, so this delta lake process similar to I have represented the diagram, this one. Okay, let me go up here. Yeah, so this is the same process, even delta layer also will process. Okay, so we have mainly like so in delta process, so raw layer is a bronze layer process, and so there is a medallion architecture in the delta. There is an important concept, that is a medallion architecture. The medallion architecture is similar to this architecture. Okay, so medallion architecture we have here, we will call it as bronze layer, and we are going to have the silver layer, and we are having the gold layer. Okay, so in this medallion architecture, so raw layer we have the bronze layer. So bronze layer, whatever the as it is data now we have represented, right? Similar way, bronze data contains only the raw information, and silver layer is a semi-structured layer, and gold layer is a fully structured layer. And we used to it's a fully structured data whatever we are delivering in the golden layer. Okay, so that's how this delta process is very robust, and any of the application you can use, and you can give the outputs, proper outputs. Okay, so that way it works, and I'll explain this SCDs while explaining the data warehousing concept. Okay, so this is just a hierarchy I have mentioned, right? So in the ADLS Gen 2, you can maintain the hierarchies. We can maintain year, month, day, and output also you can maintain year, month, day. So like that way, so your business, and you can maintain year wise how many files you are receiving, monthly and day. So like that way, so you will come to know that per day how many files you received, per month how many files you received, per year how many files you received. So all those strategies which you can learn in this data lake. Okay, Delta Lake and Delta Lake both like similar only. So we used to add this all the Delta Lake process in the data lake. Okay, clubbed up with the data lake. Data lake is nothing but your ADLS Gen 2. So we used to store our data strategies inside that Delta lake. Okay, based on our requirement. Okay, so so this is how the key features of that transactions. Okay, it is more like asset transformation, scalable. So I told you, right, asset like, so we, if you want to perform any incrementals, SCDs, so this will be very useful to perform the transactional data, and the scalable. So whatever the data increase is there to handle our big data system. So this is very flexible to increase or decrease the size of your data, and it is very stretchable. Okay, so time travel. So we have a versionings here. So version 1, 2, 3. Okay. So this open format. So open format means, example, you have a Parquet file format, you have a CSV file or some text file. So these are all the open formats. So you will get a file in CSV or a Parquet or text JSON. Those are the files it is supported to load those data. So batch system. So the schema enforcement. So if any schema is required, example, I wanted to store in a format that sales dot production systems. So you can maintain some schemas like sales or product or customer. So like that way, how example you have in SQL DB, how you will store? You will store in a DBO dot like that, right? So similar way here, you can maintain the schemas in that. Okay. So similar way it represents the schema elevation also, how the data lake table evaluation happens. Okay, and audit history. So audit history is nothing but each delta lake we are having a log. Okay, we'll come to know that. So example, you have a 1 year delta files example. So client told that on June 2023 they missed some files. So they raised some concern that on June 2023 they are not able to see their sales. So what is as a support person, as a developer, what you will do? You will check the files first. Okay, whether your file having the on the day, whether any transactions recorded or not. Okay, your first option is you will check the transaction log, delta log. So you are having one delta log folder, in that you have a transaction log. You can go and check that transaction log file, and you will get to know whether any transaction happened on 2023 June. Okay, so that way you can audit your data, your historical data. Okay, so this will be benefited for us because you can keep track on your historic and current transactional things. Okay, update and deletes. If something is any update happened inside the files, or any deletion happened in the files, or any releases happened in the files, so all those things captured in the update and delete, and this will keep a track. Example, unfortunately one person came and he deleted the input file, delta file. So we have a keep track on that file in the delta lake. Okay, so we can keep all the datas, and you can update and you can delete all those DML, like we can do the insert operations similarly, like how SQL will do, right? So all the DML operations which performs in the um, delta lake process. Okay, so this is some of the like just transactional logs which I have mentioned, right? So this will create whatever the logs. It is just like auditing. You can audit the data. So what happened to your data? It will write internally one log, so that log will be stored in the process. Okay, so this I have already explained, data warehousing. This I already explained earlier, like on-premises solutions, what is the issues? So on-premises solutions, we have so many performance issues, everything I have mentioned. And to avoid that, we have a modernized data system. So this will give the high availability, scalability, everything. This is presented in this slide. And modern data warehouse also represented. These are common. Distribution, these are distributions, so I will explain more on that. So we have a hash distribution, round robin, and replicated. So I'll give the detail information on once we start our data processing. Okay, each and every schema. So these are about today's class, more like theoretical. um, so I'm stopping here.